Evening. I'm Spot On Weather, meteorologist Matthew Euler. Welcome to my latest training video. Tonight we are going to cover fronts. And we already discussed the different types of air masses in a previous training video. And really what a front is just that boundary between different air masses. So we're going to kind of tie in the air masses with fronts. And fronts can really produce a lot of weather for us here in the middle latitudes. So let's go ahead and get right to the training. And we're going to start off with the definition of what is a front. It's simply a transition zone or a dividing line between air masses. I talked about the air masses in a previous video. These air masses have different temperatures and they have different density. And it's really cooler air masses have heavier density or are more dense versus warmer air masses which are less dense with least density. Now, these density differences are caused by changes in the temperature across the front, as well as that change in moisture across a front. So that contrast in temperature and moisture from one side of the front to the other lead to these density differences. I got a diagram here at the top, and I really wanted to just highlight a few things here with the diagram. All right, so this black line right here, that is indicative of a surface front. This is associated with continental polar air mass. And remember from the last video, a continental polar air mass is one that is cold and dry. So this particular surface front would be an example of a cold front. And then we have maritime tropical air mass out ahead of the cold front in this sector or section. And this maritime tropical air mass generally means we have a warm, moist air mass. All right, so let me draw this out here, okay? All right, so we have the colder air. I'm going to draw the arrow here. It's advancing to this direction here. We have warm, moist air associated with maritime tropical air ahead of the cold front. And that warm, moist air, the maritime tropical air, is going to be forced to rise into the vertical as this cooler, denser CP air moves in. It's going to lift the warmer, moist, less dense air off the surface, and you're going to have most likely the development of some sort of clouds and rain showers. If the atmosphere is unstable, you're probably going to get a line of thunderstorms as well. Now, I wanted to point out one more thing about this diagram at the top, okay? I want to point out that this is the height of the tropopause, okay? So this is the boundary between the troposphere where we have our weather, and above that would be the stratosphere. But I want you to notice the solid black line here. In warm, moist air, the constant pressure surface tends to get higher. So you notice in the warm, moist air associated, high pressures off to the east, we've got warm, moist air, southerly winds out ahead of this cold front coming in with the continental polar air. And you notice this line. It's associated with these constant pressure surfaces or heights. It can also be associated with that warm, moist air rising. So I just wanted to show you that. All right, now let's examine the different types of fronts that we have. We have cold fronts, we have warm fronts, we have occluded fronts, and then we have stationary fronts. And we're going to examine each one of these in depth in tonight's training. First, a cold front. This represents the leading edge of an advancing colder air mass. And typically with a cold front, behind the cold front, you're going to have either continental polar air mass, CP air mass, or a MP, maritime polar air mass. Really depends on the direction from which the air mass is coming. If it's a continental polar air mass, it's generally coming from Canada into the United States, and it's cooler and drier. If it's a maritime polar air mass, it's generally going to come, in a lot of cases, it comes into the Pacific Northwest. In addition, so coming off the North Pacific Ocean, remember a maritime polar air mass is cool and moist. And then it can also come in off the North Atlantic Ocean. All right, so this transition zone of the cold front is depicted as a blue line on a surface weather chart. The triangular points on the line, the blue line, are known as pips, and they generally indicate the direction of movement of the front. Now, how fast a front moves really is going to depend upon the strength of the upper level winds. Now, if we have very strong upper level winds, that front's going to move rather quickly. If we have weaker upper level winds, that front will tend to be slow moving. And I'll show you some examples of a fast moving versus a slow moving cold front. All right, so in general, this is a cold front. This would normally be a blue line. I apologize, it's in darker black color here, but it's a solid blue line on the weather map. And these triangles that are on the line indicate the direction in which this front is moving. So you see how these triangles, also known as pips, they're pointed in this direction. So that generally indicates that the front is moving to the east-southeast. There's typically high pressure associated with a continental polar air mass, or sometimes a maritime polar air mass behind a cold front. The cold front characteristics overall. What type of weather do we get with cold fronts? Generally, we're going to get poor weather conditions. And this is a great picture to illustrate what you would normally get ahead of cold fronts. You're going to get cumulus clouds, these puffy clouds. If the air mass ahead of the cold front is really, really unstable in the warm sector, you're going to get very tall building cumulus clouds known as towering cumulus or cumulus congestus. And sometimes if the air is unstable enough, as a cold front moves into a very warm, moist, unstable air mass, you can get thunderstorm development. So with cold fronts, I want you to think about cumulus clouds out ahead of them, gusty surface winds with showers falling out of these clouds. Sometimes you get thunderstorms with gusty surface winds as the cooler downdraft descends out of the cloud towards the ground. And again, showery precip. So it's a type of precip that starts really quick and ends really quick. And when it goes, it really pours. This is the type of precip with cold fronts that really rains hard. And then next thing you know, you look out your window and it stopped. There are two types of cold fronts that we're going to get into. We're going to talk about an active cold front and an inactive cold front. With active cold fronts, these are slow-moving cold fronts, with most of the clouds and the precipitation actually going to be at the front and behind the front. So there are some cases where a cold front will come through, you'll have the precip out ahead of it, and you'll have rapid clearing after the front passes, the cold front passes. But in this case, with an active cold front, it's a slow-moving front. Again, most of the clouds and precip are going to be at and behind the active cold front. You see the symbol here representing thunderstorms. If the polar front jet stream, along with the 700 millibar winds, now the 700 millibar winds are about 10,000 feet above the ground, if they're blowing parallel to the front, it is considered active or slow moving. So if I were to draw the upper level winds in relation to this particular front here, if my polar front jet stream along with the 700 millibar winds, 10,000 foot winds, are blowing parallel. So let's just say my winds are doing this, okay? My winds are parallel to this front. So you notice this? I'm just drawing these arrows to represent a parallel wind, in general, parallel winds. This would be my upper level winds in relation to the front. So without any kind of perpendicular wind component, this front's really going to take its time moving through an area. Now, what are the active cold front characteristics? Surface winds are gusty before, during, and after the frontal passage. The intensity of these wind gusts is dependent upon the speed of movement and the strength of the front. The stronger the front and the faster the movement, the stronger the winds are going to be. Now, wind direction is generally going to be southerly. These are southwesterly winds by these wind barbs here. Generally going to be southerly out ahead of the cold front. And then during and after frontal passage, the winds are going to veer around to the west and northwest. And this is mainly in the northern hemisphere here when I'm talking about this wind direction change. So ahead of cold fronts, winds are generally from a southerly direction, in many cases southwest, behind a cold front from the west and northwest. You can see this little indicator here, this little table here on the bottom right. This is showing the frontal passage indicators for barometric pressure. With pressure before the active cold front, the slow-moving cold front comes in, before the front gets in, you're going to have a steady pressure fall. During the frontal passage, you're going to have a sharp pressure rise, and then after, that pressure is going to kind of steady itself out. It'd be more of a steady rise. So this is an active cold front. Now here are the active cold front characteristics kind of encapsulated into one slide. Temperatures are going to drop suddenly with frontal passage and continue to get colder with time. So this is one of those rapid temperature drops with active cold fronts. The dew point, the measure of moisture in the atmosphere, is going to be higher before frontal passage. We have a lot of moisture. Those southerly winds and southwesterly winds are really going to infect or bring lots of moisture ahead of the active cold front. And then the moisture is going to drop just slightly during frontal passage. Visibility is going to be fair to poor during the frontal approach and generally is going to be poor during frontal passage. And then with active cold fronts after frontal passage, the visibility is good, except in those showers that are behind the front itself. Let's turn our attention now to the inactive cold front. Now this one is a fast-moving front with clouds and precipitation ahead of the front. So look at this diagram here on the right-hand side. This symbol here generally indicates thunderstorms, and you kind of see this white area, which is enclosed by these dark lines. That represents your cloud coverage. So clouds and thunderstorms and showers are going to be out ahead of the inactive cold front. The upper level winds are also going to blow perpendicular to the front. And in many cases with this type of front, the fast-moving inactive cold front, you're going to have a line of showers and thunderstorms. Sometimes it forms what's known as a squall line, 50 to 150 miles ahead of the inactive cold front itself. This is an inactive cold front because right along the front itself, and especially behind it, you don't have any weather. But it is a fast-moving front. Let me draw out, just kind of indicate again these upper level, mid and upper level winds. With a inactive cold front, you notice the difference. The winds are from this direction, and these mid and upper level winds are perpendicular to the front. So that's going to push this front through much quicker and speed up its motion. With inactive cold fronts, they are responsible for severe weather, to include strong thunderstorms. If you get a really, really warm, moist, and unstable air mass, you're going to get tornadoes ahead of these inactive cold fronts. A squall line, that's that distinct line of thunderstorms, it can develop 50 to 150 miles ahead of the inactive cold front. Surface pressure does not rise sharply during frontal passage. It is more of a gradual pressure rise. Additionally, with inactive cold fronts, temperatures do not drop suddenly during frontal passage. The temperatures are going to drop gradually. Surface winds will veer around slowly from the south to the southwest ahead of the front, and then northwest well behind the front. The dew points are going to drop sharply with the inactive cold frontal passage. And all weather changes are going to occur more slowly with inactive frontal passages as compared to active frontal passages, with the exception of the dew point, which drop more sharply. All right, so we covered a cold front. We talked about the general weather and some of the elements of the weather that change with this cold frontal passage. We talked about the two different types of cold fronts. An active or slow-moving cold front with the weather at and behind the front, and an inactive or fast-moving cold front with the weather well out ahead of the front. Now let's change gears and talk about a warm front. Warm front is simply the leading edge of an advancing warm air mass. It's depicted on a weather map as a red line with half circles on that line. The half circles on the line indicate the direction of frontal movement. So over here on the right, again, apologize, these aren't in color, but you generally have an area of low pressure. Let me go ahead and get my pen back out here. So you got low pressure right here. This letter L represents your lowest barometric pressure, okay? You've got your cold front, which is going to be extending southwest from the area of low pressure. And then you get a warm front, which generally is going to extend east or sometimes northeast of this low pressure center. All right, so this is what we want to talk about right here, where I put an X. This was what's known as a warm front. It's known as a warm front. The warm fronts generally in the northern hemisphere are going to move towards the north, and in some cases northeasterly. The half circles on this warm front indicate the direction of movement. You're going to have cooler air to the north of a warm front, and you're going to have warmer air to the south of the warm front. The winds are actually going to change direction, as you may have more of a northeast or easterly wind north of the warm front, and then that wind is going to basically shift around to the southeast and then the south and southwest. Warm frontal characteristics, head of the front and the cooler air. Okay, So look at my graphic here in the upper right. This is my cooler air. I got easterly winds at about 15 knots. But the clouds are primarily going to be stratiform in this sector here in the cooler air. Visibility will be poor in the stable atmosphere ahead of the warm front, with continuous precipitation falling. In wintertime, it's very common to have fog and very low clouds, specifically stratus clouds, ahead of a warm frontal passage in the wintertime. You will get continuous precip. Sometimes you get just continuous drizzle or that mist that kind of floats in the air with very thick fog. Wind is usually going to be east, southeast in the cooler air ahead of the frontal passage. And then if the atmosphere is unstable, you can get thunderstorm development with warm fronts moving in. But again, the air mass has to be very unstable. Here's some of the indicators down here in the bottom right as far as barometric pressure with warm frontal passages. Before the warm front, the pressure falls. During the warm frontal passage, the pressure kind of levels off, becomes steady. And then after the warm frontal passage, there's a slight barometric pressure rise, followed again by a fall. To sum up warm front characteristics during the warm frontal passage, the wind becomes variable with a south-southwest wind right after frontal passage. Temperatures are going to be cool to cold ahead of the frontal passage or before it occurs, the front occurs, with a steady rise in the temperatures during frontal passage. And after frontal passage, of course, those temperatures are going to become warmer with a more unstable atmosphere developing. Here's warm front characteristics, some of the weather elements, just to again re-summarize everything. Dew points are steady before the warm front arrives with a slow rise in the dew points during frontal passage. And then after the warm frontal passage, the slow rise of dew points continues. Eventually it steadies out over time. Visibility will be the poorest before the warm frontal passage with a slight improvement during, and it generally becomes fair to poor after warm frontal passage. And clouds and precipitation are generally out ahead of the warm front, as that warm moist air rides up and over the cooler air at the surface. So here's a quick review of the cold fronts, the cold active and the cold inactive fronts. Over here on the left, we have active cold front, which is just a quick summary again. This is showing colder air moving into an area, the warm air being lifted ahead of that colder air, ahead of the cold front. And again, with an active cold front, we generally have a slower moving front with precip at and behind the front with active cold front. With an inactive cold front, it's fast moving. Generally, you have this colder air moving the front's moving at a quicker speed. The winds in the upper levels are more perpendicular to the front, and this warm air is lifted rather abruptly, and that results in clouds and precipitation well in advance of the inactive, fast-moving cold front. Review of warm fronts. Let's take a look at this. If we look at a top view here in the bottom left, I'm just showing you cold air is moving in with this cold front. You got warmer air ahead of it. And right in this area here is going to be your warm front with the semicircles on it indicating the direction of movement towards the cool air towards the north. And in the side view in the vertical of the warm front, you see the colder air in the left portion of the diagram. This is your cold front right here, your frontal surface. And then you got warm air lifting out ahead of the cold front. And then even in advance of that, let's just get this here. We have warm moist air, which is going to ride up and over cooler air at the surface. So you see the cooler air at the surface. This is your warm front right here. This line represents your warm frontal surface. So more of a gradual rise in the air, of the warm air over the cooler air at the surface, is generally associated with a warm front. Additionally, the slope is more gradual with a warm front. You notice the frontal surface here with the cold front, this is a much steeper slope as compared to this line, which is not as steep. It's kind of more gradual. So in general, this is a review of the warm fronts. Now let's talk about another type of front that's known as an occluded front. Now this is going to occur when a cold front, it moves faster than a warm front, and basically what happens is it overtakes it. It overtakes the warm front. It lifts the warm air completely off the ground, and depicted on a surface weather chart as a purple line with alternating pips and half circles indicating direction of movement. Here's an example of an occluded front and what you would see on a surface weather chart. Your occluded front in this diagram over here is going to be represented by this frontal surface here, okay? right here. So you have a semicircle, and then you have a pip on the frontal line on the weather map. This is actually going to be a purple line. And so what happens here is the cold air, it's moving, the cold front is moving faster than the warm front, and that colder air catches up to the warm air and lifts it completely off the ground. And so this results in an occlusion. Cold front overtaking a warm front. When you see occluded fronts, it's generally going to be in the more mature stages of a mid-latitude cyclone. You'll see this quite frequently, specifically in the fall and in the winter time, even in the early spring. Very intense low pressure systems. Occlusion occurs in the latter stages of a low pressure system, its life cycle. Two types of occluded fronts we have. We have a cold occlusion and a warm occlusion. So let's examine these. A cold occlusion occurs when you have very cold air behind the cold front, actually forcing the cooler air ahead of the warm front aloft. The coldest air is actually with a cold occlusion behind the cold front, and that warm front is going to be forced aloft. And the surface weather changes are very similar to that of a cold frontal passage when you have a cold occlusion. So let's take a look at a cold occlusion over here on the right with the diagram. So one thing I want you to notice is you have very cold air to the basically behind this cold front. You have colder air ahead of the cold front, but you have very cold air behind it. So what happens is the cold front overtakes the warm front, lifts the warm air completely off the ground, and what you have remaining is very cold air behind this occluded front and just cold air ahead of it. Here's another example here. Cold air is very cold here behind the cold front. You got cold air, but not as cold ahead of this. I shouldn't say cold front. This is an occluded front. So very cold air behind the occluded front and just colder air ahead of it. The warm air is completely aloft at this point in time. So with cold occlusion, think the very coldest air is going to be behind the occluded front, and cool air is ahead of it. Here are some of the characteristics of cold occlusions. The barometric pressure generally falls before the frontal passage, with the lowest readings during the cold occluded front passage. Pressure is going to rise after passage. The surface winds are normally south to southeast before cold occlusion frontal passage, then variable during passage, and then west to northwest after passage. The temperatures will be cold to cool before frontal passage, and then you'll have dropping or falling temps during passage, and even colder air after the cold occlusion frontal passage. So again, cold occlusion characteristics are very similar to a cold front. Additionally, with the dew point with cold occlusion characteristics, it's generally steady before the frontal passage, but the dew points will drop slightly during and after frontal passage. And the visibility will be generally poor before and during frontal passage, and it will improve after the cold occlusion frontal passage. For warm occlusions, now we got a little difference here. We got the coldest air ahead of the occluded front. We have just cool air behind the occluded front. So coldest air ahead of the occluded front, cool air behind it. So air ahead of the warm front is going to be colder than the air behind the cold front. As cooler air behind the front catches up to the warm front, again it rises up and over the colder air ahead of the warm front, and the cold front is then forced aloft because it is not the coldest air mass. So this has to do with where's the coldest air, okay, in relation to the occluded front. If it's just cool air behind the occluded front, the coldest air is ahead of it, what you're going to do is you're going to get this cool air is going to be less dense and rise up and over the coldest air at the surface. If you get this cooler air here, right, the point of occlusion is going to occur right where all the air masses meet. Warm occlusion characteristics, the pressure, the wind, the dew point, and the visibility are similar to that of a cold occlusion. Temperatures are cold before frontal passage, warm during passage, and then milder cold to cool after passage. And finally, let's talk about stationary fronts. These are a front. Basically, a stationary front is a front that does not move or moves just slightly, and neither air mass is advancing toward each other. Identifying a surface weather chart with pips and half circles on alternating sides of the front. And the surface wind with a stationary front is generally going to be parallel to the front, but going in opposite directions either side. This is an example of a stationary front right here. We have cooler high pressure to the north of the front. You have cooler air north of the front as well. South of the stationary front, you have warmer air. One thing to keep in mind is we have easterly winds north of the stationary front, and we have westerly winds south of the stationary front. So these winds are blowing in opposite, parallel directions to each other. All right. With stationary front characteristics, the weather is very similar to warm fronts, with continuous precipitation a lot of times and poor visibility. The weather is usually on the colder side of the front. That's where you usually find the weather of the stationary front, on the colder side of the front. And the front can persist for days, but usually weakens with time. If the warmer air begins to move and replace the cooler air, it turns into a warm front. But if the cooler air begins to move and replace the warmer air, it becomes a cold front. So we have a cool air mass to the north, the warm air mass to the south of stationary fronts, the winds blowing parallel in opposite directions to each other, so the front just simply doesn't move. Stationary fronts can really persist in an area for days and result in poor visibility, specifically for airports. And then finally, let's talk about the frontal system intensity changes. Fronts undergo intensity changes. Let's talk about a couple terms that describe this frontal intensity change. Frontogenesis will describe when fronts form, strengthen, or regenerate. Whenever you have frontogenesis, it's identified by an increase in temperature contrast or difference across a front. So if that temperature contrast across a front is increasing or getting stronger or greater, you generally have frontogenesis. Frontolysis, on the other hand, is a weakening or dissipating of a front. Frontolysis is quite a common thing that occurs during the summertime. When you get a cool front to move south, eventually the air mass contrast between one side of the front to the other side it becomes similar, and so the front just weakens or dissipates. And in frontolysis, that weakening or dissipating of front is identified by a decrease in that temperature contrast or difference across the front. Here's what you would be looking for frontogenesis. Okay. Now these dashed lines on this particular graphic or slide, they indicate these are isotherms, lines of equal temperature. And they range from plus 5 degrees Celsius up to plus 20 degrees Celsius. So you notice the packing of these isotherms, these lines of equal temperature. When the packing is further apart of these isotherms, we have a weaker front. But watch what happens over here on the right. These dashed lines, these isotherms, become more tightly packed. This is going to indicate frontogenesis. This means your air mass contrast is increasing, specifically in this case on the cold side of the front, which means this front is strengthening and undergoing frontogenesis. If I look at frontolysis, it's the opposite. Look over here on the left, these dashed black lines again indicate your isotherms, lines of equal temperature, ranging from plus 5 C to plus 20 degrees C. Notice how tightly packed these lines are. Notice this, how tightly packed these isotherm lines are. Now look over here on the right. See how they start spreading apart a little bit more? So, temperature gradient, when it's stronger, you're going to have tightly packed isotherms, and when it's weaker, you're going to have more widely spaced isotherm. So this is a case of frontolysis, or a weakening of this front over time. All right, that wraps up my training video tonight on fronts. These are big weather makers for us in the mid-latitudes. Whether you're in the U.S. or Europe, it's very common to see fronts always interacting with various air masses. But in general, I just wanted to kind of cover the basics of fronts. I've got a lot more training to come, including my next training video will be on convective severe weather fundamentals, I've got severe weather fundamentals part 1, severe thunderstorm fundamentals, or severe weather fundamentals type part 2. And then I go into some additional stuff such as the Earth-Sun heat budget relationships. And then we'll get into troughs and ridges and the type of temperature advections, what they do to those particular troughs and ridges. I've got a lot of great training material ahead. I hope you enjoy these training sessions. I hope you're getting a lot out of it over the course of this summer. And I've got a lot more to come. So thank you for subscribing to the Spot On Weather YouTube channel. I do appreciate it. And until next time, take care and God bless everyone.